Let me give you an example of curvature. So in this video, we're going to work out the curvature of a circle, of radius A, and remember, sometimes we would use R, sometimes we would use S. So S represents the distance along the actual path, and then if you differentiate this, it would give you R prime. But then sometimes we would use V dash. So just bear that in mind. These are just notations. You've got to be able to jump back and forth. Okay. So in the previous two videos, we looked at curvature, and it's given by this. So to work out the curvature of a circle, we just blindly follow this formula here. So first step is to work out the tangent. So from our R, if we differentiate it, it will give us the tangent. So from R here, so this is R. If we differentiate it, so this is our position vector. If we differentiate it, it will then give us our velocity vector. So differentiate this, that will then give us this thing here. Because differentiate this, that will then give you this. Differentiate this, that will then give you this. That will then give us our velocity. That will then give us our velocity. But then we want the tangent, the unit tangent. So we would need to work out the magnitude of this length. And then let's say the magnitude is 7. Then we'd need to cut it into 7 equal parts, and then we will have a unit tangent. So let's start again. From our position vector, differentiate it. That will then give us the tangent. But then we need to that will then give us the tangent. We would need to divide it by the magnitude of the tangent. Well, the magnitude is given by us using Pythagoras, and then square root everything. So that will then give us this. Tidy this up, it will then give us this, and then this thing here is just the number 1. Square root of the number 1 is 1. So the magnitude is given by A. So let's start again. We started out with our position vector, differentiate it. That will then give us our tangent, but then we need to divide it by the magnitude. The magnitude is given by this. So our unit tangent is given by the velocity, which is given by this, and then we would need to divide it by the magnitude, which would be this. So it's going to be this whole thing divided by A. So basically this would cancel out with this would cancel out with this. So our unit tangent would be given by this. Okay, so remember, it's this divided by this, which is this divided by this. That will then take us to here. Now we've got our tangent, our unit tangent. Now we need to differentiate it with respect to time, because at the moment everything's in terms of time. It's not in terms of s. It's in terms of time. So now that we've got our t, this is our t here. We will need to differentiate it with respect to time. So now we need to differentiate it. So this quantity here is given by us differentiating this with respect to time. So differentiate this, that will then give us minus cos. Differentiate this will then give us minus sine. So this bit here is given by this. But then we now need to work out the magnitude of this quantity here. So now we need to work out the magnitude of this thing here. Well, the magnitude of that thing there is us squaring this, and then square root it. So that will then give us this thing here. Well, this thing here is the number 1. Square root of the number 1 is 1. So this thing here, so remember our formula for curvature is this thing here, which is the number 1, times by 1 divided by the magnitude of the velocity. Well, the magnitude of the velocity is this thing here. This is velocity, and then the magnitude of velocity is A, and we've seen this. So the magnitude of velocity is A. So going back to here, this quantity here is the number 1, is the number 1. This thing here is the number, well, is A. So kappa, the curvature, is given by this thing times this thing, which is 1. And then the whole thing here will be this. So the curvature is given by, if you're looking at a circle radius A, the curvature is 1 over the radius. So if you look at, well, our final answer is actually 1 over A. Kappa is equal to 1 over A. But on a side note, something different. If you have a curve like this, the curvature, well, you can draw a circle of best fit. So it fits the curvature perfectly. So it's like this. And then if you look at this circle, the tangent of this circle and the tangent of the curve, that will be the same, and the normal of the curve and the normal of the circle would, well, it would go through the center of the circle here. The curvature of this curve is actually 1 over the radius of this circle. So if you look at the curvature right here, okay, so you draw a circle that best fits this region here, and then looking at the tangents of the curve and the circle, they will share the same tangent, they will share the same normal, and it goes through the center of the circle, and the curvature at this point here will be 1 over the radius of this circle. Just bear that in mind. You don't need to understand this for the time being, okay? But just have that at the back of your mind. Well, the final answer, the curvature of the unit circle of our scenario up here is given by 1 over A, okay?